Question number 30. The two straight lines shown in the displacement time graph intersect at the motion represent the motion of two objects A and B. Start from rest and time t equals 0 and moving along the positive x direction. Which of the following statements made about the motion of object is true? First statement, the object A has travelled for a longer time than B. It is incorrect. We can consider x-axis. X-axis, it means time axis. Displacement time graph. For the first object, object A and object B. This time is a constant value t naught. Therefore, both objects has the same time period. Then first statement is incorrect. Second one, when t equals t naught, object B has made a displacement greater than B. We can get displacement of B by using area of this part. And displacement for the second object, object A, by using area of this part. We can consider, according to the graph, this area is approximately equal to this area. Therefore, area of motion of B is equal to motion of A. Then second statement also incorrect. Third one, object A has a greater velocity than B. Object A has a greater velocity than B. Yes, it is correct because of we know that gradient of displacement time graph is representing velocity. Gradient is a higher value for the graph A. Then third answer is the correct answer for question number 30. Then question number 31. Positions of three motor cars, 1, 2 and 3, traveling along three parallel straight lines of road at time t equals 0, t equals t naught are shown in figure A, and their corresponding velocity time graph shown in B. The situation shown in figure A could have happened only if the area of graph satisfies the conditions. We know that for the motion they have represented initial and final positions of cars are same. It means gradient of velocity time graph should be same. The motion of first object, first car, is represented like this. Second car like this, and third car like this. Velocity time graph. And displacements of three objects are same. Therefore, area of velocity time graph for the first car should be equal to second car and should be equal to third car. I will consider first and second cars. Then this area for the first car should be equal to this area for the second car. And we know that this part is common for both objects. Then this triangle, area of this triangle should be equal to area of this triangle. Then we can get BCD area BCD area should be equals to EDF area. BCD means this part. EDF is this part. And then I will consider motion of third object. With second object. Area of this part. For third object, area of this part should be equal to for the first object, area of this part. It means this area, this triangle should be equal to this part. Then we can get ABD triangle. ABD triangle is this one. It should be equal to DGF triangle, this one. Because of we know that this part is equal to this part according to this theory. And this triangle, ACD triangle should be equal to DEG triangle. But we know that this part is equal to this part. Therefore, we can consider only these two parts. Then, second requirement is ABD area equals to DFG area. Then, answer is 2 for the question number 31. Then, question number 32. A ball is dropped freely to a floor, a height of 1 meter. If its speed reduced by 25% at each bounce, what would be the height of the ball reaches after 3 bounces? I will consider for the first part, initial downward velocity 0, final velocity v. I will find the final velocity. We know that this distance is 1 meter. We can use v squared equals u squared plus 2as. We have to find v value, final velocity, u0, 2 times acceleration 10, displacement 1. 2 into 10, 20, root 20 is the velocity. Root 20. And the velocity is decreasing 25%, reduced by 25% at each bounce. When bouncing, its velocity is 3 over 4 of v. 25% means 1 over 4. 1 over 4 v is reducing. It means upward velocity should be 3 over 4 v. And we know that this kinetic energy for this space should be equal to potential energy for maximum height reached by the object. Then we can get half mv squared equals mgh. Then considering natural star cancelling because of it is common for both terms, we can get v equals 2gh. We can subject h value v squared divided by 2g. This one is constant for the motion. Then height is directly proportional to v squared. Now we can consider for the first bounce, velocity becomes 3 over 4. And for the second part, for the second bounce, it will reach with this velocity to the floor and it will rebound again. Then rebounding speed should be 3 over 4 of 3 over 4v. It is the velocity for second rebound. When it is rebounds in third part, velocity should be third rebound 3 over 4 of magnitude of this part. 3 into 3, 9 over 4 v. Now we can get this one is 3 over 4 cube v. 3 over 4 into 3 over 6 in this part 9 over 16. 3 over 4 into 3 over 4 into 3 over 4. Then final velocity is this one. If the first for the first part for the first rebound, velocity 3 over 4 v. V means final velocity colliding with the flow for the first instant, and for the second rebound, velocity should be 3 over 4 of 3 over 4 v. For the third rebound, velocity should be 3 over 4 of value of this one. Then we can get for the third rebound, velocity is this one. Now I will consider if the object is rebouncing with v velocity, it should be reached 1 meter height. And we know that square of velocity directly proportional to height. Then if the velocity, rebouncing velocity is v, it should rebound to 1 meter height. And if it is rebounding with this velocity, 3 over 4 cube v, we can consider rebound height is h, square of velocity directly proportional to height. Then we can divide both the equations. Then dividing these two parts, we can cancel out v square. 1 divided by square of this one equals to, I will write it, 1 divide, I will write it as reciprocal. This term divided by 1, 3 over 4 cube square divided by 1, we can write without 1, equals to h divided by 1, h divided by 1. Then h value is this one, we can simplify it. When simplifying power of power, we have to multiply indices. Then 3 over 4 to the power 3 into 2, 6. It is the rebouncing height. 3 over 4 to the power 6. Answer is 4 for the question number 32. Then question number 33. The figure shows the displacement time graph for the motion of two cars with respect to a lamp post beside the road. Consider the displacement to the right side of lamp post as positive. A student has made the following statements regarding the motion of cars relevant to the points P, Q and R marked on the graph. Statement A, relevant to P. Car 1 coming from left, cos car 2, cosas car 2. Displacement time graph is like this. For the car 1, it is starting from a minus displacement time graph. It means lamp post is at this place. Then car 1 coming from left. Yes, it is coming from left and move to plus direction. Plus direction is right hand side. It is given in the question. Cross car 2. Yes, when considering car 2, its motion is like this. But car 1 and car 2 goes at Q position, not P. Therefore, first statement is incorrect. Statement A is incorrect. Then statement B, relevant to Q, both cars moving towards the lamppost and cross each other. Yes, it is correct. No, both cars are not moving towards the lamppost. For the first car, it is moving towards the lamppost for this part, and it is moving from the lamppost for this part. It is like this. If lamppost is this one, motion of first car is like this, from this point to this point. And motion of the second car is like this. The crossing point is like this one. At this place, second car is moving towards the lamppost, but first car is moving from the lamppost. Then B also incorrect. Statement C, relevant to car 2, coming from right, passing the lamppost. Relevant to R, R is this place. Relevant to car 2, coming from right, passes the lamppost. Yes, it is correct. Statement C is correct. Only C is correct. Answer is true for the question number 33. Then question number 34. The figure shows velocity time graph for an object moving along a straight line. What is average velocity of object from t equals 0 to t equals 4? We can consider graph is like this. Velocity at this place v. There is a constant free velocity for 3 seconds, and for the last 1 second, velocity is 1. We have to get average velocity. We know that average velocity is total distance divided by total time. Then we can consider total distance, area of this part is representing distance for this graph, 3 into 3, 9, plus area of this part, 1 into 1, 1. Total distance is 10. Then we can write average velocity is distance, total distance divided by total time. Total distance 10 divided by total time 4, 2.5 meters per second. Then third answer is correct answer for the question number 34. Then question number 35. Positions of particles of transverse waves traveling along plus x direction. A certain instant is shown in the figure A. Figure, a pair of particles with same instant velocity. Velocity is same instant velocity. Then considering motion of wave, we know that point A is at rest, velocity 0. Point B, velocity 0. Point B has a velocity in this direction. Point C has a velocity in this direction. Point B, point C. Again, point E has a velocity in this direction. And F has a velocity in this direction. Now we can consider C and E, or B and F. B and F has the same velocity, same direction, same magnitude. Or C and E with same velocity. But in answers, they have given B and F only. Then answer is 1 for the question number 35. Then question number 36. The displacement time st graph for the motion of an object is shown in the figure. The corresponding velocity time graph would be represented by. I will draw the displacement time graph and corresponding velocity time graph. Displacement time graph is this one. It is given in the question. We have to select corresponding velocity time graph. We know that gradient of displacement time graph is representing velocity. Gradient is decreasing for this part. It means velocity should be decreased. Velocity should be decreased. We can consider it is like this. Velocity is decreasing to 0 because of gradient for this part is 0. Therefore, velocity is 0 for this part. This part is parallel to the time axis. Therefore, gradient is 0. And for this part, gradient increasing, but in same direction, not opposite direction. Therefore, we have to consider it should be like this. Sorry, like this. Velocity is fast for both situations. Then third one is the correct answer for question number 36. If the object is moving in opposite direction, we have to draw velocity time graph like this for the answer. But it is moving in same direction. Therefore, we have to consider velocity at this part and this part should be positive. Then question number 37. A ball is thrown vertically upward from the ground. The time duration between two instances that the ball passes the point at a height 25 meters, height of 25 meters on its path from the ground 4 seconds. What is the initial velocity of the ball? Neglect air resistance. They have given velocity of, they have given when considering motion of an object projected in upward direction, the time interval at a height of 25 meters, this time interval is 4 seconds. 4 seconds. It means velocity at this space should be 20 meters per second because of it is moving 2 seconds in upward direction after passing this point and 2 seconds in downward direction. We know that velocity is decreasing 10 meters per second for a considered 1 second time period in upward direction, and velocity increases 10 meters per second for 1 second time period in downward direction. Therefore, motion for this part is 4 seconds, then motion for this part should be 2 seconds. It means 20 meters per second, 10 meters per second, 0 meters per second. Velocity should be like this. Then we know that velocity at this space is 20. We have to find initial upward velocity. We can use an equation from A to B. A to B, I will use v squared equals u squared plus 2a in upward direction. We have to find final velocity. We have found final velocity 20. 20 squared means 400. Initial velocity we have to find it u squared plus 2 into gravitational acceleration is in downward direction, but we have used equation in upward direction, therefore minus 10 is the acceleration. This displacement is 25 meters. They have given 25 meters. Then displacement is 25. Now we have to simplify it. U squared equals 400 25 into 2, 50. 50 into 10, 500. We have to bring it to the left hand side as a minus term. 500. U squared is 900. U is root 900. 30 meters per second. It is the initial velocity of the motion. Then answer is 3 for the question number 37.